Hello, everyone. I'm Mike Pitaro from Dell Technologies, and I'm going to be today's host for this session on modernizing your data architecture with an enterprise data platform presented by Cloudera. We're going to handle QA at the end of the session, but during the session, I'm going to be monitoring the chat and we'll coordinate all the questions at the end. So there'll be plenty of time for QA. I'd like to introduce today's speakers. First up, well, together we have Ali Bajwa, who's the Director of Partner Solutions Engineering at Cloudera. And we also have Amir Bamanyari from Dell Technologies, and he's an advisory engineer working closely with our customers in the field. And I'm going to hand off to Amir. He's going to kick us off with the first couple of slides, and then he'll pass things over to Ali for the rest of the session.
Sure. Thanks, Michael. Let's start with the Hadoop as a paradigm and its evolution rather than a technology component. So in the past, Hadoop started from a MapReduce engine, which was processing the data that was already persisted in HDFS silo. And now we're witnessing that Hadoop is basically adapting as an evolving paradigm and not just a technology component. Along this path, there have been many asks and to cause artifacts that derive this Hadoop's paradigm evolution. For instance, disaggregated software stack. It's been asking for two separate concerns on a standalone storage, compute, security, governance, etc. There has been demand for extremely large scale capacity to allow running unscalable cloud-like commodity hardware. And that will not be limited to just an on-prem infrastructure limitations. And also at the same time, there have been asked to conform to the open source data standards and conform to open source formats, etc. Last but not the least, there have been expectations to evolve Hadoop to be adaptable and extendable to changes that happen in diverse underlying technology ecosystem components. Next slide, please. Okay. And along with this journey that continues with the data considerations, and on-prem and cloud Hadoop versus Hadoop-powered private cloud. And this is affecting many silos, such as use cases, and it's affecting technology infrastructure, and it's also affecting the user experience on deployment time and how much it takes. And throughout the lecture, the webinar today, we will be diving pretty deep into these. And next slide, please, Ali. So, so far, the evolution path has basically evolved the big data challenges. Analytics by through three generations. As far as the generation one, it all started with on-prem monolithic blocks of Hadoop clusters, and then it transformed to Gen 2 single-purpose transient clusters in public cloud, and still not useful for stateful applications. But currently with Gen 3, we are witnessing that it's leveraging best of the two, Gen 1 and Gen 2, and it's also on top of that, it's also useful for stateful application. This is basically the topic of this webinar, and Ali Bajwa from Cloudera would be taking us deep into the details of the newly released Cloudera Data Platform, CDP 7.1, tool to modernize existing big data architecture. Ali, please go ahead and take control.
Thanks, Amir. And
sure, you're welcome.
Happy to be here. So, hey, good morning, guys. Good afternoon, guys. So let's start with a brief overview of the brand new Cloudera Data Platform. So there's a couple of key differences on how you may have, experienced either, Hadoop from Cloudera or Hortonworks in the past. So one of the key things now is that whereas before we only had sort of a single experience, which was the Hadoop experience, where you pick a distro, you pick your components, and you kind of install them and everything. Now we have this notion of these brand new analytical experiences. And the idea there is that these are cloud optimized. So they come with auto scale, suspend, and resume capabilities. So the idea is that, rather than have to worry a lot about, sizing and all these kind of things, these things all auto scale. So it doesn't matter what size you start with. As you're, for example, with the data warehousing project, you can think of that as either Hive or Impala running on Kubernetes. As the queries come in, the system automatically auto-expands and gives you more compute. And after the queries stop running, for example, you don't get any new queries for 3-4 minutes, it'll automatically time out and scale down. So it kind of gives you that auto scale up, suspend, and resume capability, so you can better optimize your, more efficiently use your hardware. And the other, and this basically gives you an example of how you can optimize your workloads based on analytics and machine learning. So we essentially have 5 different experiences that we'll eventually have. Currently, we have primarily the data warehousing experience, which I mentioned is sort of a SQL experience, so either Hive or Impala running on Kubernetes. Or you have the machine learning experience, which is essentially the Cloudera data science workbench running in a Kubernetes fashion, where in a couple of clicks, you can spin it all up without having to do any sort of manual work there. And again, the system automatically scales up and down based on your GPU and CPU requirements. In the near future, we'll also have other experiences around data engineering, which will be essentially Spark on Kubernetes, as well as data flow and streaming, which will be essentially Kafka and NiFi, Apache Kafka and Apache NiFi running on Kubernetes. And then sort of a private cloud optimized version of HBase, which is the operational database. One of the key aspects, the other key aspect of this new platform is this sort of separation of these compute experiences as well versus the actual state. So on the previous slide, we talked about how this kind of gives you best of both worlds, where the IT can basically still have some control over security, governance, and all those kind of things. But then the individual business unit can have full flexibility on what type of compute they want to spin up, whether they want to have one compute per business unit, or they want to have one compute potentially per even team. And the way that's done is this notion of SDX, which is our secret sauce, which contains this notion of state, and that's kind of shared across all the different computes. So this long-running cluster running the state doesn't have any compute of its own, but it keeps track of all things like schema, catalog, replications, security, and governance, essentially using Hive Metastore, Apache Ranger, Apache Atlas, and so forth. And so while this is keeping track of state, you can spin up and down all these different computes, and rest assured that that the security policies that were implemented by the admin at the time of install, they will be respected by all the different computes as they come up and down. And then all the lineage for all the new kind of tables that are created by these different computes, they will all be sort of kept in this common SDX layer. And then finally, this can be deployed on any sort of infrastructure, whether it's public cloud, multi-cloud, private cloud, and so forth. With that, we'll get into the details of the CDP data center and private cloud form factors. So the first form factor we're going to talk about is CDP data center. And the best way to kind of understand that is we essentially took the best of breed between the legacy Hortonworks and the legacy Cloudera, so HTTP and EDH. Combine them together, put together some new features, wrapped it with Cloudera Manager, and that's where CDP Data Center comes into the mix. So it's essentially the first CDP on-prem product. It comes with 20 plus components, and it's highly customizable, where you have that same Hadoop experience as in the past. So it's a net new distro where you can pick and choose your components. So if you're familiar with doing things from the past, this is this form factor is very familiar with you, where you can just pick your components. You have a tool like Cloudera Manager to basically manage them and configure them and hook them up and wire them up all together. So some of the key things for CDP Data Center, why you'd want to look at CDP Data Center. So first reason is there's something new for everyone. So regardless if you're coming from the legacy Cloudera side or the legacy HTTP side, there's something new for you. So on the legacy Cloudera side, one of the common asks used to be around security, where Sentry didn't support things like dynamic row filtering, dynamic column masking, attribute-based access control. Now we get all of that as part of Apache Ranger, which is the standard security tool of choice as part of CDP. On top of that, there were also requests around Hive, so a better Hive. So with Hive 3, which is available in CDP, customers get access to ACID support and comprehensive SQL ANSI coverage, better ETL performance with Hive on base. And then similarly, if you're coming from HTTP, you get all the benefits of Cloudera Manager, Impala, Q, and Kudu, which were missing, and you can kind of see the details here. And then finally, for both sides of the house, there's net new capabilities like virtual private clusters to be able to separate compute and storage, brand new Atlas, as well as a tech preview of a new object storage called Ozone. The other key reason why CDP-DC is important is that our legacy lines, HTTP and CDH, will eventually be end of support. The first lines which will go end of support at the end of this year are HTTP 2.x and CDH 5.x. So, and the details are mentioned there on the website. So the key thing that folks need to understand is that since those are going to be end of support by end of the year, customers running those need to upgrade to a supported version. Even though you can go obviously to CDH 6 and HTTP 3, we're encouraging a lot of our customers to move to CDP so that they only have to do one big bang, one upgrade rather than multiple hops of upgrade. And this kind of diagram shows some of that. So today with CDH 5.13 and HTTP 2.65, we're encouraging all of those customers to do the single upgrade and move over to CDP Data Center 7.1. However, there is still the option to upgrade to CDH 6 HTTP 3 this year, and then at the end of by the end of next year, move over to a CDP Data Center. But again, that will incur a multi-hop upgrade. So the third reason why CDP Data Center is important is that it is also the foundation for containerized applications. So I talked a lot about the brand new containerized applications I'll be running on Kubernetes. So how will you get access to those? So once you've actually moved over to CDP Data Center 7.1, you can actually hook this up as a base cluster to an OpenShift cluster where you would be running those Kubernetes experiences with the CDW and CML that will be coming by end of summer as part of our CDP private cloud offering. And we'll cover that in a little bit more details, but essentially the CDP Data Center cluster will be a baseline or foundation for that CDP private cloud. Next, let's look at the latest release and what's coming next. So we recently released CDP Data Center 7.1, and as part of that, there were 3 key components. So first thing was the support for in-place upgrades. So with 7.0, it was install only to get customers a feel for what CDP Data Center looked like, but it didn't actually support doing in-place upgrades from previous releases like CDH 5 and HTTP 2. So now those are actually supported, and we are basically targeting, again, HTTP 2.6.5 and CDH 5.13 plus, because that's where 70% of our customer base is. So that was the first idea behind 7.11. Next is we were looking to complete some missing features. So there were some features missing in 7.0. So we were trying to fill in most of the remaining gaps over there. So components like Knox and some others were what landed. And then CDP Private Cloud is the support that we just talked about. So a little bit more details on what came about as part of 7.1.1. So as I mentioned, we're supporting the in-place upgrades now for CDH 5.13. So as long as you're on a recent build of CDH 5 or HTTP 2, we should be able to upgrade you, as well as anyone who had previously installed CDP Data Center 7.0. Here's some more details on the different components that additional components that got added, like Knox and Zeppelin and other things that folks may have been familiar with from the legacy lines, and a whole bunch of other kind of features came in there. What was not added was in-place upgrades from CDH 6 or HTTP 3. and those will essentially be coming in a subsequent release. So we're going to be towards the end of the year and early next year, we'll be coming up with a bunch of new fixed pack releases, so 7.1.x, where we'll be periodically adding more and more capabilities, starting from things like Accumulo, Ubuntu, SLES, in-place upgrades for CDH6 HTTP3, and then we'll also be looking to add Isilon support as well. Now, for a customer perspective, how do you actually get to CDP data center? There's two paths to getting there. First is to actually do a migration to CDP data center, where you're building a new data center and essentially copying the data and metadata from the classic cluster. And the other path is doing an in-place upgrade on the same hardware. So there's different pros and cons of each, and we'll look at those in a little bit more detail. So if you're looking at the migration option, where you're essentially standing up a brand new CDP data center cluster. So who is this good for, right? So if you think about this, some of our customers have been running legacy CDH HTTP for a while. It may be a good time to refresh on the hardware side, just because of, with private cloud coming in, the OpenShift requirements are a little bit more than what they were in the legacy Hadoop. So some customers may decide it's a good time to do re-architecture. And an easy way, one way to do that is to just be able to stand up a brand new cluster. So you have zero downtime and a way that you can set up, brand new infrastructure with new server configs, new network, new OS, new platform, and so forth, rather than having to worry about upgrading the legacy. And the process is outlined here. Essentially, you provision a new cluster, identify which workloads you want to migrate. And the idea is that over time, you would migrate all your workloads. And then finally, decommission the legacy environment. And then the other option is around in-place upgrades. So this is optimal for situations where you don't have the additional hardware capacity and you want to use the same cluster. In a lot of cases, legacy customers may have large single-tenant clusters, so it might be easier for them to just do a in-place upgrade rather than have duplicate environments for each of them. And also for organizations where you have multiple clusters, so you can do testing of those upgrades in lower environments. Next, let's shift gears and talk about CDP Private Cloud. So what exactly is CDP Private Cloud? So as I mentioned, it gives customers access to a new set of data analytics applications, which are all essentially running on container cloud. So this has been an ask for many of our larger customers for a while, is that, hey, we've embraced Kubernetes. When are you guys going to be looking into Kubernetes? So CDP Private Cloud is the best way to do that with on-prem. And then, so the high-level idea is that there'll be a shared data lake. So essentially, your CDP data center becomes the base or foundation, as we talked about earlier, which will keep track of, which will have your data as part of either HDFS or Ozone. And then it'll also have this notion of SDX, your shared state with security, metadata, and governance. And then you'll have a separate OpenShift environment where you will have all the different Kubernetes-based experience. So your Kubernetes, your containerized compute will be coming as part of the OpenShift cluster, and then you'll have your base CDP data center cluster where you'll have your data and your shared security, shared state, plus any other bare metal workloads you may want to run. So let's talk about some of the use cases of private cloud. So the first use case is around consolidating small tenants. So in a lot of cases, some customers may have, maybe one large monolithic cluster, but then a bunch of smaller clusters. So the idea is that with private cloud, you would be able to consolidate those smaller clusters and essentially reduce costs of, having to manage multiple copies of the data, having multiple clusters and so forth. And so the idea is anytime you want a net new cluster for maybe a new BU or anything like that, you can just give them their own sort of workspace on private cloud. The other use case could be around isolation of unhappy tenants. So let's say you have a legacy environment, either CDH or HTTP, and you have the issue of noisy neighbor problem, and then as a result of that, you have some unhappy tenants. So the idea is that you could either move or promote those unhappy tenants or move those noisy neighbors over to CDP private cloud, so they kind of prevent any issues from coming aboard on the main cluster. We'll be providing tools like Replication Manager to be able to essentially migrate over any data sets needed over from the each side of the house. And essentially, this is basically kind of like copying from on-prem to cloud as well. And then finally, the last one is a burst to private cloud. So the idea here is that you've already upgraded your legacy cluster to a CDP data center cluster. But at the same time, you have some workloads that you may want to, do a sort of burst to cloud kind of scenarios, where again, you have some workloads which are missing SLAs. And so potentially you could use tools like Workload Manager to figure out which workloads are essentially missing their SLAs and might be good candidates to burst to private cloud. And then you can essentially do the same where you burst them to private cloud. So let's get into the architecture of CDP private cloud, where it looks like. So essentially, like I mentioned, there'll be two clusters. You will have your same old bare metal or VMs around where you would stand up, your traditional Hadoop environment. So this will be running CDP data center, but then you'd also need a separate set of nodes where you're going to stand up OpenShift, and those requirements are a little bit different. And once you have those bare metal VMs where you're going to have your data center, you're going to install your Cloudera Manager and use Cloudera Manager to stand up your CDP data center cluster. So again, this could have been an in-place upgrade, or it could be a net new install. And as part of that, you'll need to install the SDX components like that keep track of state. So your data, HDFS, and HMS for metadata, Ranger for security, and Atlas for governance. And once you have that, you can basically install the management console on that OpenShift cluster by using Cloudera Manager to register that. And then once you have your management console, it'll have the capabilities around the new experiences that we will have available as part of CDP private cloud, so CML and CDW. And you will now be able to use that management console to create your environment, which is kind of linking together, this OpenShift cluster, which has your compute capacity, as well as your data lake cluster, which has your data and your shared state. And once you have that environment done, you will be able to basically use, again, that management console to create things like the CML, Cloudera Machine Learning Workspaces, to be able to do things like Spark on Kubernetes or Python or R. Or you can use, if you're more interested in SQL, you can use the CDW experience to basically stand up these virtual warehouses and essentially be able to, be able to just bring your data and start querying through SQL without, having to stand up and do sizing around different clusters and all that kind of thing. So hopefully that gives you a good idea of what the architecture of CDP private cloud is going to look like. So with that, we'll go into our last section, which is around Cloudera machine learning. And so one of the key things that, one of the key challenges that our customers run into is that, when they start looking at machine learning, they think most of the effort is going to be around writing the machine learning code, but they quickly figure out that, ML within an enterprise and a, enterprise or production level grade sort of implementation is much more than just the ML code itself, right? There's this whole cyclical process around how do you collect the data, how do you verify the data, make sure all your machine resources are there, how do you do analysis using that ML code, how do you extract the features, how do you deal with the processes around this. In a lot of cases, all of this needs to happen in a sort of shared environment where multiple data scientists are working, where multiple data engineers are working. And then finally, once you have a ML model, how do you actually serve that model in a performant way that where it can be used for production use cases? And then probably the most important, how do you monitor that model to make sure that it's still performing the same way when you first implemented it? compared to now? Has it actually lost any accuracy or all that? So this is where Cloudera machine learning can sort of help. So the key tenets around Cloudera machine learning is around it gives data science teams self-service access to the data. So essentially, whatever they need, each team can have their own workspace, and where they can basically start sharing data and compute and open source tools that they need to build their models. With workflows, essentially it's built for teams, so to be able to do modern collaborative processes with reproducible software and development practices. And then finally, you can actually deploy this anywhere, again, whether it's private cloud, public cloud, or hybrid. Because of CDP, the way it all works is that we support it all. And then some of the key things that are now available as part of CDP and CML is that we have a preview of Apache Spark 3.0, which is brand new. And that's available as an add-on on top of CDP Data Center 7.1. It'll also be coming in CML as well. The key features around Spark 3.0 is around, first of all, performance. So Spark 3.0 performs a lot faster. So if you look at it from a CDS perspective, we have expanded the language support. So if you look at Scala 2.12, JDK 11, Python 3.6, and a lot of other improvements. There's a lot of information. You can grab a screenshot of that link if you want any more information. So finally, in terms of next steps, how you can learn more, how to implement some of this using the CDP using Dell. So there's a couple of resources that we've made available. So we've worked together with Mike and the team to build a reference architecture for CDP Data Center with 7.1.1. Where you can get into full details of everything that we just talked about is available in the white paper on the different strategies in terms of getting to CDP, as well as what sort of hardware you'd be looking to do, and then what are the capabilities that CDP provides. And then as you're looking to move towards private cloud as well, we also have put together hardware guidance in consultation with both the product teams on Dell and Cloudera side to basically provide some guidance on if you're looking to move to OpenShift later, what would the hardware configuration look like for the OpenShift clusters from a storage perspective, from a memory perspective, but then most importantly, what would the network links look like between the two as well, because that's going to be one of the key factors. So both those assets are available, and I see that Mike has also posted the links to those in the chat. So that was my last slide. So at this point, we can stop and see if there's any questions. Happy to take any feedback or answer any questions that folks may have.
Thanks, Ali, and thanks, Amir. Yeah, so we did have a couple of questions come in during the chat. Let me find the window here. I've been monitoring them, but I forgot what they said. So early on, we had an interesting question. You had mentioned earlier that Kubernetes is running under the covers. We had a question: is the Kubernetes effectively hidden from the user, or can the sophisticated user tweak settings? I think you touched on that a little bit. I'll hand you the whole question again.
Yeah. So essentially, the idea is that it sort of depends on what level you're at. If you're sort of the admin, then obviously, the admin will be the one responsible for setting up the OpenShift cluster and basically getting it hooked up to the CDP data center cluster and all that. So obviously, that admin would have full access, and we would need that admin to have full access on that OpenShift environment. In fact, initially, we're going to be requiring a dedicated OpenShift cluster to be used for CDP private cloud. In the future, we'll be looking to share, existing OpenShift environments and so forth as well in future releases. But then the idea is that from a, business user from the BU perspective, right? That once they've been provisioned and given access to that CDP management console, they potentially may not even know that Kubernetes is running under the covers, right? From their perspective, they'll just open up the CDP management console, and from there, depending on what experience they're looking to use, whether it's the data warehousing or the machine learning, they'd be able to go in there, provision or get into their new workspace and just start using the software without really even, potentially knowing what's there under the covers. So it gives you both, essentially.
Another question that came in earlier. I knew this one was going to come. So, timeline for Isilon support in CDP 7.1. I know it's in progress right now, so we should probably say that and probably the reasons why. But do we actually have a date yet?
No dates yet. I think so. We're in the final processes of finalizing the sort of testing agreement between the two companies. And my understanding is that it's going to be, best case scenario, 6 months after the agreement is signed, with a worst case scenario of 9 months once it's signed. So we're hoping to get it all signed by in the next week or two. So that's sort of the latest that we have. But yeah, it's in progress.
Yeah, and I'd also this comes up quite often. Since Isilon implements the HDFS protocol, it needs a much more rigorous testing as kind of a core storage layer compared to other things that are just using public APIs. Consider there really is a plug-in into the whole ecosystem. So
yeah, that's a great point. So yeah,
the testing is just more rigorous.
Because Isilon is essentially emulating HDFS, we need to do rigorous testing to make sure that all the components that sit on top of HDFS, when they interact with Isilon, it's exactly the same as it would be when they interact with DAS. So there's essentially hundreds of tests that are run as part of that QATS test framework to make sure that our customers are getting the best experience.
And here's another interesting question. So the question is, should Cloudera Machine Learning be viewed as basically the new Cloudera Data Science Workbench? It says workshop here, but I think it meant to say Data Science Workbench.
Yeah. So essentially, yeah, you can think of it almost as a rebranding of Cloudera Data Science Workbench. And so the idea is that whereas before with CDH, if you had to install Cloudera Data Science Workbench, there was a fair amount of effort required to set it up in terms of sizing and configurations and all that. So we're trying to make it as easy as possible, where for obviously within some initial setup, after you set up OpenShift and all that, the idea is that from the business user perspective, right, they can just go in and click a button to provision a workspace, and within a couple of minutes they'll get a workspace that's fully provisioned. But at the same time, they can provide flexibility where they can kind of configure what's the upper and lower limits of the number of CPUs this workspace should use, or the GPUs that this workspace should use. So it kind of gives you the flexibility of just the ease of being able to provision it with a couple of clicks, but at the same time, the complexity of being able to configure, how much of your overall compute and GPUs should it be using.
Yeah, that's true. And for anybody that was running Data Science Workbench, it included its own kind of little Kubernetes and its own little world.
Yeah.
That has now moved to the private cloud side. So you have a full Kubernetes environment out there under OpenShift. So I think it's kind of the new Data Science Workshop or Workbench, but also you're running the other workloads out there as well on that same environment. So that's interesting. We had another question here. Do you have any features like DremIO and generally virtualization of data? That's kind of a roadmap item, I believe.
Yeah, so for some, depending on the use case, there's so obviously there's a number of SQL engines that come with the platform at this point, right? So if you look at CDP Data Center at this point, we've combined the best of breed between HTTP and CDH, so you get a lot of capabilities with Hive, especially with Hive 3, with ACID, and all of that. Then you have capabilities that Impala used to provide. We have that. Now we have Phoenix also as another SQL engine in there. You have Spark SQL as a SQL engine in there. Spark is a little bit interesting because there's a lot of customers do virtualization of data using Spark, where you can essentially get data from different places using Spark as an RDD and then kind of do a merge, right? And essentially now have a new table or a new view, which is based on a sort of a virtual view across different locations. But at the same time, we work very closely with partners as well. So right now, we are working with third-party ISV partners to get them all certified on CDP. Some of the customer capabilities can be provided that way. Obviously, we never say that we're sort of a one-stop shop and you don't need any other vendors. We're working with our ETL and BI tools and all the other kind of gambit of ISVs that are out there. Specifically on virtualization, would be looking to work with folks like Denodo and Big SQL and others around data virtualization. And similar with Alteryx, I saw Alteryx come in as well. So Alteryx is another partner that we'd be working with.
Yeah, so it's interesting. We had another question there. Is it possible to have some features like Alteryx, especially in Data Science Workbench?
Yeah, so yes, depending on what exactly is being looked on. So one of the things that potentially you could ask for around Alteryx is this notion of some sort of a data catalog with this notion of data profiling and data quality. So we will have actually one of the components that will come as part of the management console. So we'll provide some tools as part of the management console. Some of those I alluded to in the presentation. So things like the workload manager to basically figure out which workloads can be easily migrated. Replication manager to actually copy over and replicate data sets between different environments. But then the one I didn't talk about was data catalog. So we actually have a full-blown data catalog that will be part of the CDP. And you can think of data catalog as a mixture of what Data Steward Studio provided on Hortonworks and Navigator provided on Cloudera side, plus Atlas as well. It's kind of a hodgepodge of all of that. So essentially the idea is that it'll be able to do things like you'll be able to run things like data profilers on your Hive and HBase tables to figure out what's the profile of the data there, get some recommendations on where, for example, sensitive data may be like, hey, this, you'd get alerts to say that, hey, this column in this table looks like a credit card column. Maybe we should tag it as sensitive or credit card or something like that. And then the data steward would have the option to accept that tag and then set up potentially tag-based policies on that. So there's a lot of data profiling and data quality type capabilities also coming in as part of CDP, as part of data catalog.
Well, thank you, Ali. As we wrap up here towards the end, there was one other question that came out, and it was related to whether slides were available, and I'll answer that one. The way we're handling this, the sessions have been recorded, and they'll be available. I'm going to put this into the chat window, but they'll be available on the site sometime tomorrow at aianalyticsreimagined.com. So I think it's going to be the full recording, not just a slide deck.
Excellent.
So with that, I'd like to thank our presenters and all the participants that joined here today for this session. And there is contact information, I think, on the beginning, but please feel free to reach out to us if you got further questions or interest.
Thanks for participating.
Thanks all. Thanks for having me.
Thanks all.